The nation's history is far more a record of industrial victory than a saga of wars waged and battles won. Its greatness lies in glowing furnaces and smoking stacks, in skilled labor, inventive genius, and the spirit of enterprise that is so typical of America. And typical of the steel industry, literally the backbone of 1,000 industries, is the panorama that reveals the magnitude of any one of the major mills where the manufacture of steel involves a tremendous investment. Here, before a worker can be given a job, the company by which he is employed has an average of more than $11,000 for each man employed, and that does not include wages. Incidentally, note one unusual feature of this industrial scene, which would not be found in any other country in the world. The automobiles are who work in the mills, men who are now age rate in the history of the industry. Into such a center of activity, the raw materials are poured from train and ship. Thousands of tons of coal for the blast furnaces, mountains of iron ore, and vast quantities of limestone. They are charging a furnace, ore from which the iron is to be melted, coke to provide an intense heat in the base of the furnace as a superheated air blast passes through it, limestone to flux the impurities from the ore. Up to the top goes the laden Larry to feed one of these giants that may eat up as much as 3,000 tons of solid raw materials a day. Now they are preparing to tap a furnace at the base, where they may draw off as much as 100 tons of molten iron at a time. An oxygen torch burns into a clay-plugged hole, but no chance for injury on this job. That asbestos suit and helmet would protect any stray sparks or spatters. A thin stream of metal begins to flow, glowing liquid iron. The stream swells in volume, a fiery river if you ever saw one. But you, as an uninitiated onlooker, could not be expected to know that these men in charge are very much in command, with modern mechanical devices and highly developed safety measures that enable them to control the flowing metal with less danger to themselves than you face every day in your home or on the street. Today, the American steel mill is as safe a place to work as any industrial establishment. In fact, company after company has prided itself on winning safety trophies, which stand for a prolonged period without a single serious accident. A sample of the metal will be cast into a small block and cooled for a quick analysis by the metallurgical laboratory to check its quality. Meanwhile, the flaming river is directed through channels which lead to the edge of the tapping floor, where it spills into huge ladles resting on flat cars. Ladle after ladle is filled, until finally the laden train is on its way across the yard to its destination, the steel-making departments, where the molten iron in the ladles will be poured into a large container called a mixer, holding many tons, and here kept hot, so that it can be used in its molten state in one of the 3 major processes in making steel. Of these, the Bessemer converter process is the oldest for producing a tonnage product available at low cost for a multitude of uses. Here stand the operators in safety behind shatterproof glass. Number 3 is going to pour. One of the monsters, like a huge egg with the top sliced off, tips over on its trunnions and pours into a ladle its load of steel that glows like the sunset and shoots millions of sparks through the dim traceries of girders and all down the length of the arena. Very different from the spectacular Bessemer is the squat little electric furnace, which makes special steels because of its smaller capacity and the ease with which it can be controlled so accurately. From this process come the high-grade alloy steels, such as stainless and all sorts of special steels with special qualities. And then there are the open hearths. While the roaring flame and fireworks from Bessemer converters still provide a thrilling spectacle, and capacity for producing steel in the electric furnace has been increasing in the last few years, 90% of steel today is produced in open hearth furnaces because of the demand for tailor-made steels in large quantities, which can be produced with this flexible and efficient method. And by the way, there is one interesting factor in the making of steel just as important as the virgin iron, fresh from ore smelted in the blast furnace. It is scrap. Most of the scrap metal will be found en route to the open hearth department. Remelted scrap steel constituting about 50% of the total steel produced today. There's a carload of sheared ends. There's another. And there's a car that may hold all that is left of your 1929 automobile, now on its way to become part of a steel, and a better steel, perhaps for your next car. In this huge structure, the open hearth floor, which is typical of American steel mills, a long line of furnaces holds steel in the making, steel that will someday enter your life, perhaps carry you safely on some journey, provide you with shelter, create an endless variety of comforts and conveniences. A supply of finely ground dolomite has been piled before the furnace that is to be charged. It will melt like glass and fill any holes that may have been burned through the lining by the previous heat, forming a solid bottom for the fresh charge. Then the charging begins. From the trainload of scrap which has been brought close to the furnace, an electric charging machine lifts box after box and pushes its burden through the door of the furnace. The operator sitting at a safe distance, spinning the ram and dumping its load. There is the rumble of a giant traveling crane overhead, moving in with its burden. A huge ladle of molten iron from the mixer, where it has been awaiting this final step in the process of becoming steel. They are placing the chute into position for pouring the charge. And as the crane draws near, note that the men actually handling the metal are either sheltered high up on the crane in the cab or operate electrical controls across the floor. There goes the charge, 50 tons of white-hot liquid metal heated to approximately 2,800 degrees Fahrenheit. Hazardous, frightful danger in this job? Not at all. Millions of dollars have been spent by modern steel mills of America for safety. Devices are employed which not only protect the worker from molten metal, from metallic dust and from flying chips, but also from human carelessness. The automation of steel production has made work simpler and safer. Men are not doing dangerous jobs that the machine can do more safely. But more men and more competent men are required to control the machine. And the safety achievement of the steel industry is a high tribute to the intelligence of these men who work in the mills. Like good cooks, they must know the temperature of the brew, and they measure it on an optical barometer while it boils in a white-hot pool as big as a fair-sized room. And like good cooks, they even take several samples of the brew, using a long-handled small ladle to pick up enough liquid steel to cast a test ingot. It congeals almost instantly and is soon dumped out and handled quite readily. When it is cooled, it will go to the metallurgical laboratory for a thorough but quick examination before the metal from which it was taken is drawn off to be made into steel. Thousands of different kinds of steels are made like this every day. Each steel, strange as it may seem, a custom-built product. Each different steel, the filling of a prescription, to be of a certain hardness, to be soft, flexible, dull, bright, to be tailor-made for each one of thousands of uses. Now they are ready to tap a big one, and they must reach across to the opposite side of the furnace to break through the clay plug tapping hole from the inside. But the place to see the spectacular part of the operation is on the other side of the open hearth furnaces, where an asbestos-clothed worker burns through the exterior of the clay plug tap hole with an oxygen torch. A few more ramming blows with a long tapping iron, and there she flows. 200 tons of steel produced according to specifications for one of an infinite variety of uses. Just the proper percentages of carbon and other elements are retained in every heat of steel so that it will possess the exact characteristics needed. Men on the platform will shovel in the correct amounts of spiegel, ferromanganese, ferrosilicon, or whatever agent the metallurgical laboratory has prescribed for this particular heat of metal. Higher and higher it mounts in the great ladle until the slag, the undesirable portion of the charge, rises to the top like froth and overflows to find a future usefulness as a byproduct in other lines of business. The electric crane moves into line to carry the ladle to the pouring platform, where a train of cars bearing the ingot molds is waiting. When this molten metal has been poured into molds, the basic business of making steel is ended. Thereafter, it is only a matter of fashioning from the ingots the form of product desired. The steel man says that this fiery liquid freezes immediately in the mold. He means that it congeals when its temperature goes down 1,000 degrees or so, and within an hour is frozen too hard on the outside for rolling. Thus, it is not of a uniform consistency. So after the molds are stripped from the ingots, weighing from 5 to 15 tons apiece, the huge castings are hauled away to a furnace called a soaking pit, in which they are heated until of the same temperature throughout, and which holds them at exactly the right heat for the anvil of the modern blacksmith, the rolling mill. Now this steel is fairly on its way to you, because in this one chunk of white-hot metal there may be thousands of cans, kitchen utensils, or perhaps the materials for automobile bodies, refrigerators, and innumerable things in everyday use. And this universal use of steel is possible because its cost is only 2 or 3 cents a pound, the lowest of any important metal. The wide strip continuous mill made it possible to provide sheet steel wide enough for the all-steel automobile body and the one-piece steel top on the models of today. It is one of the many great advances in the art of steel making, which has brought a saving to the consuming public in the form of lower prices for better steel, amounting to nearly $300 million a year, compared with costs of 10 years ago. Automobile users alone are saving $75 million a year. But in spite of more men are needed in the mills, and employment is now at the highest level in the industry's history. There goes that ingot you saw, now a hot slab, flattened and elongated, on its way to further reduction. Now reduced by further rolling to the size of armor plate. And now becoming a huge strip, several feet wide and less than 1/4 of an inch thick. It moves to the table where it will await its turn in the coiling machine. Coiled hot, it is subsequently cold rolled flat after passing through an acid cleansing bath, 2 processes which vastly improve the smoothness and polish of the surface before it is cut into the lengths prescribed by the factory to which it is to be delivered. In general, only the rarer metals such as gold or platinum have ever offered much resistance to corrosive attack until the steel industry developed stainless steels which have made this metal practical for an endless variety of uses wherein it combines beauty with resistance to rust and corrosion. Look at that polish, a permanent mirror-like surface, perhaps destined for some swanky cocktail bar or the kitchen of a modern home. Here is an operation which constitutes in itself a critical test of steel, the piercing of a solid billet to form a seamless tube. And here is another interesting operation, also a critical test of steel, the making of a car wheel. The wheel must retain its specification factors of strength and ability to take it when subsequently it will be pounding over the rails. On another mill, a big ingot begins to take form with a first rough rolling, becoming elongated as it passes through another roll, and then assuming a familiar shape as we see the outline of an H column, destined for some skyscraper or perhaps a great steel bridge. The operators of the mill, up there above it and completely shut off from the heat of that white-hot steel, turn it, spin it around, roll it by pressing buttons or throwing levers, and finally deliver it at the far end of the mill a completely finished job. Steels pass through various mill processes or combinations of processes in order to make them suited to a wide variety of uses. In any giant ladle of molten metal, there may be steel that is destined to defeat time and distance, to provide the framework of mighty buildings, and to enter into the daily life of every citizen in thousands of things that provide comfort and convenience with economy. The call for steel from every section of America is a demand for a basic material without which life and living standards as we know them today would be impossible. Steel has kept pace with and anticipated the increasing needs of the nation. Men and steel provide a nation with its comforts, its luxuries, and its progress.